Okay, so we are still under the method folder, but now we are not in the method selection or modification. We're going to change to the parameters, essentially the pure and binary parameters. So let's define a parameter. What's a parameter according to Aspen Plus? Is any constant used in the many different physical property models or equations used by Aspen Plus in order to predict physical properties. So important points right here are either models or equations that require constants in order to calculate physical properties. Okay, so that's essentially the thing. It's any numerical value that will be inputted in a model equation in order to predict a physical property. The good thing is that for many components, Aspen Plus databanks will store all the required parameter values. So for water, we don't need to find the parameter for viscosity because Aspen Plus has it already. So that's good. Now I really love that Aspen Plus separates parameter and data. What's the difference? Parameters are constant use for equations, and equations will get numbers. Those numbers will be used for models and so on. Now data is actual experimental values, input data. So this is different. This is a calculated value and this is an experimental value. Okay, so very important to keep in mind because we are going to see a folder later on called data. Let's check out an example of parameter. No, don't worry, we will be revisiting this section right here because we are going to be working a lot with parameters. So we are in the parameter folder. We go to the pure components and each one of them, let's say CPIGDP, is most likely CP, which is the maybe specific heat capacity of an ideal gas changing pressure. Maybe it's parameters right here. So the components: water, ethanol, pure substances. As the property unit, I'm pretty sure the unit is okay. Is CP. How are you calculating CP? Well, I need this set of parameters. These are the parameters, guys. So this is not raw data. These are parameters which come from databases.